Good evening, everyone. This is lecture number 13 in electrostatics, and we are on to electrostatic potential energy. In the previous class, we had seen what is potential energy, how we can find out the change in electrostatic potential energy. We had seen what was a conservative force, and we had seen how this potential energy comes from a conservative force. We had seen the relation between conservative force and change in potential energy. Yes or no? The work done by the conservative force, the negative of the work done by the conservative force is the change in potential energy. And this is a diagram that you must remember. You can also write it like this. I mean, if I can just continue on what I was writing, I can also write it as negative of F dot dr. Now remember, this F is a conservative force. In the case of electrostatics, this is electrostatic force. So you can write it like this. Or if I take out the negative side, it becomes UA minus UB. It is the work done by the conservative force. Now, as soon as we understand that the change in electrostatic potential energy is defined as negative of the work done, we can also define, or we can also understand one more term which is going to come. Everyone has noted this down? Electrostatic potential, or you can call it electric potential as well. Electrostatic potential or electrostatic potential difference. Electrostatic potential difference. Now, how do you define this electrostatic potential difference? It's written by the letter V. So VA minus VB, the difference in potentials between 2 points, VA minus VB, is simply UA minus UB divided by the charge. If I move a positive charge from point A to point B, there will be a change in electrostatic potential energy. That change in electrostatic potential energy per unit charge becomes your change in electrostatic potential, or the difference in electrostatic potential energy per unit charge becomes your difference in electrostatic potential. Do we understand this? Yes or no?
Yes, sir.
So, now you can understand this concept of electrostatic force, electrostatic field, electrostatic potential, and electrostatic potential energy in this way. Suppose you have a point charge. I don't have a point charge. Suppose you have a point charge in this space. Now what is this point charge going to do? It is going to create an electrostatic field around it. So you have an electrostatic field around it. Now, because of this electrostatic field, which is a conservative field, at all the points in this space, we have electrostatic potential. Now, it is difficult to imagine this electrostatic potential and electrostatic potential energy, but it is easier to imagine gravitational potential or gravitational potential energy, because we can see it in our day-to-day life. So we can take the example of gravitational potential energy and take the analogy to electrostatic potential energy. We are experiencing gravitational field of our planet Earth, which is very strong. We can see this. So we are right now experiencing gravitational field of Earth. Now, because of this gravitational field of Earth, all these points which you see around you, infinite number of points, they all have gained some gravitational potential, but it just remains like gravitational potential. If I now place a mass at any point on this gravitational field, now this mass attains gravitational potential energy, because now this mass can do work. gravitational field, it creates gravitational potential. It is only potential, it cannot do anything unless and until you put a mass. When you put a mass, that becomes the gravitational potential energy of this body, and now it can do work. So this is the way you can understand electrostatic potential and electrostatic field and electrostatic potential energy. Whenever you have a charge, it will create a field. Right now, if I imagine that there is a field created by some charge, that field creates electrostatic potential all around itself. If I now put a charge in that electrostatic field, that charge will now carry that electrostatic potential energy, and that charge can do some work. Do we understand this?
Yes, sir.
So I can now write, this is change in energy divided by Q. So I can write it as integral of F dot dr, or this is integral over length. Okay, let me write as the integral of F dot dr divided by Q. Yes or no? Change in energy divided by charge is F dot dr divided by Q. Now F by Q, force divided by charge, becomes your electric field. So you have this relation between electric field and potential difference. VA minus VB, which is also your UA minus UB by Q, can now be written as integral of E dot dr. Do you understand this?
Yes, sir.
I can write this formula in the reverse order as well. If I have to find out the difference in energies between 2 points, what do? I multiply this charge by VA minus VB. Yes or no? Electrostatic potential difference or electrostatic potential or electric potential difference. Remember, what type of quantity is this? This is a scalar quantity. You can see a dot product over here. So it is a scalar quantity. What is the SI unit of this? What is the SI unit? Energy is joules. So you can call it joule per coulomb, or it becomes joule per coulomb becomes volt. The SI unit of electrostatic potential or electrostatic potential difference becomes joule per coulomb or volt. Do we understand this? Yes or no?
Yes, sir.
Now remember, as we had seen in the case of electrostatic potential energy, the absolute value of electrostatic potential energy is not defined. What is defined is the change or the difference between 2 points. Similarly, the absolute value of electrostatic potential is also not defined. Then what is defined? What is defined? The absolute value of electrostatic potential is not defined. Remember, to find out the absolute value of anything is not possible because everything is relative. And it holds very true for electrostatic potential. Absolute value of V or electrostatic potential is not defined. Then what is defined? Only change in potential or potential difference is defined. Only change in V or difference of potential is defined. Do we understand this? Yes or no?
Yes, sir.
Now, sometimes what we are going to do is, in some cases, in some general cases, we can take the potential of infinity to be 0. Now, if potential of infinity is taken as 0, which is possible in some cases, then you have a reference whose potential is 0. Then you can define the potential of different points. Do we understand this? Yes or no? If you take the potential, of infinity to be 0, if you can take it, then you can define the potential of any point. And how you can define the potential of any point? If I take the potential of infinity as 0, you just have to put infinity in the equation and you get the answer. You just have to put infinity in the equation and you get the answer like this. Work required in moving a point charge Q from infinity to point P. The electric potential of point P is work done by external force in moving the charge from infinity to P, keeping the kinetic energy ka change 0, or it is negative of work done by electrostatic field in moving the charge from infinity to point P. That is how it is defined. Don't get confused. It is the same thing that I written in VA minus VB. If you take one point as infinity, point B as infinity, you can get the potential of point A as work done by external force or negative of work done by electrostatic force. Do we understand this? This is how it is defined. Again, here I have assumed that potential of infinity is taken as 0, which in some cases will work, in some cases it is not going to work. So in some cases we cannot define absolute potential because even infinity ka potential cannot be taken as 0. Do we understand this? Yes or no? This is how electrostatic potential, which is a scalar quantity, is defined. Now, this is the way electrostatic potential is defined. This is the same way in which gravitational potential would be defined. The only difference would be instead of electrostatic force, you will have gravitational force. And in place of Q, charge, you will have mass. But there is one more difference between electrostatic potential of a point charge and electrostatic potential created by a point mass. We'll see that difference. Do we understand this? Yes or no? Everyone now has an idea of what is electrostatic potential and how it is defined, and how can you find out the potential difference between 2 points? Yes or no? Shall we move ahead?
Yes, sir.
Sir.
Everyone understands this? Okay. Now, the next heading would be electrostatic potential due to a point charge. But before going on to this, I can see these properties. So we can just write these properties together so that we don't have to look here and there. So you can write these qualities, these properties which we have already discussed, and I will add some more points so that they become full. Potential is a scalar quantity. Do we know this? Yes or no?
Yes, sir.
It is a scalar quantity. It may be positive, it may be negative, it may be 0. The SI unit is joule per coulomb. You can also call it as watt. Then electric potential at any point is equal to the negative of the work done by the electric field in taking the point charge from the reference point, which is taken at infinity, to the point about which we are talking about. Electric potential created by a positive charge is always positive, and due to a negative charge is negative, except at infinity, whose potential is sometimes taken as zero. Potential decreases in the direction of electric field. We will discuss this topic in detail, don't worry. Now, if you have more than 1 point charge and you have to find out potential due to more than 1 point charges, how will you find the potential? So we will discuss this point, the yellow one. Since potential is a scalar quantity, you can simply add potentials due to different charges as numbers and just throw them away, because it is a scalar quantity. So potential can be added or subtracted just like numbers. Do we understand this? Do we understand this? Yes or no? We call this as the superposition theorem. You can write if you want to. We had seen the superposition theorem of electric field. You can also write the superposition theorem of electric potential. Since potential is a scalar quantity, you don't have to worry about directions, whether it is going like this or going like this. You just find out the potential and add, because it's a scalar quantity. So you can just add it. Okay. So far, so good. Any doubt up till now?
No, sir.
Okay. I'm trying to make everything clear in as many okay, I think this is enough. Rest is just repetition. I'll give you 2 minutes to note it down. Note it down aram se. And remember, whatever we are doing for electrostatic potential or electrostatic potential energy is also valid for your gravitation, which we will do as soon as we finish your thermodynamics. So the same thing can be continued over there. So we will be finishing up your 2 of the topics together. That is how I see it, because it becomes easier for me to take the analogy and do that topic. Let me know once you are done, beta. And once you understand this concept of electrostatic potential, it becomes a very good tool, because electrostatic potential is a scalar, and as soon as the scalar comes, life becomes simple, because we don't have to think about the direction. Whenever the vector is there, the direction thing will always trouble you. But as soon as the scalar comes, direction says bye-bye. Things become pretty simple that way. So remember this concept of electrostatic potential or electrostatic potential difference. Remember, absolute value of electrostatic potential is not defined. What is defined is the difference only. To define the absolute value, you need a reference point whose potential can be taken as zero. You can take the potential of any point for that matter to be zero. In the chapter on work, power, and energy, we had taken the potential of Earth, gravitational potential of Earth as zero, but it is not zero. It is not zero. Have you understood this? Yes or no?
Yes, sir.
Everyone has noted this down.
Yes, sir.
Shall we move ahead?
Yes, sir.
Okay.
Pakka, sir.
Okay. Now, the next thing that we are going to do is the next heading is electrostatic potential due to a point charge. Electrostatic potential due to a point charge. Electrostatic potential due to a point charge. I'm not going to get into the derivation of this part. How I'm going to derive this? Can anyone tell me how I'm going to derive this? So basically what I got to do is I got a point charge. Let us take it as positive plus Q. Plate at this point A. And I will have to find out the electrostatic potential it creates at this point P. Obviously, I must know the distance. Let us say that the distance is R. The question is how I am going to find out the electrostatic potential at this point. Now, first of all, the absolute value of electrostatic potential is not defined. So first of all, I have to find some reference point whose potential can be taken as 0. Where is that point? Where is that point? Nowhere, sir. Go and search it. Where is that point whose potential can take 0 in this case? Is there a point? Or no, sir? There is no point. I'm asking you a question. Huh?
Point P, sir.
Point P is the reference point. No, point P ka the potential I have to find out, beta. If I take that as reference point, potential becomes 0, life becomes simple. Take point P as 0, sir. Life is 0, then what did you find? I can't take point P as 0 because I have to find the potential of this point. So that trick
At infinity, sir.
at infinity. So I will have to look at the point, and my reference point here is infinity. So first of all, I must understand that I have taken the potential of infinity as 0. Now, if I've taken the potential of infinity as 0, what I need to do is I would first of all need to bring a positive charge, or I'm not going to bring it. Electrostatic field will have to move this positive charge which I have to go to infinity and put a positive or a negative charge over there. I have to put a positive charge. I have to put a positive charge over there. Then I will have to ask electrostatic field, hey, electrostatic field, please bring that charge from infinity and place it at this point. And then I will find out the work done by electrostatic field in doing this job for me. And then I will divide it by the charge itself. That will give me the potential of this point. And I'm not going to do that exercise because we don't have time for that exercise, and that exercise is of no use. We just understand how it is done, and that's it. The potential of this point P is given by K Q by R. That is what is important. And since this is a positive charge, it will be plus KQ by R. And remember, the potential of infinity is taken as 0 in this case. Remember, because if this is not there, we cannot define the absolute value. The potential of point P is plus KQ by R. Okay, do we understand this?
Yes, sir.
We also know the electric field at point P. How much is the electric field at point P?
Q by R square, sir.
KQ by R square. Let me not write it as a vector. So KQ by R square, and the direction is away from the positive charge. Okay. Now, if I take I have to remove this. Let me take here. Let me take a point Q here. Let me take a point Q here. Now, simple question I'm going to ask. Q and P, both are in electric field, so both have potentials. Whose potential is going to be more? Potential of point Q or potential of point P?
Point Q, sir.
Potential of point Q is going to be more because it is nearer to me, so I will create more potential there. Potential is influence. If you are closer to me, you will be influenced more. If you are far away from me, you will be influenced less. So potential of point Q is more than potential of point P. Yes or no?
Yes, sir.
If I draw the direction of electric field will be going like this. Yes or no? From a positive charge, electric field lines are always going away. Yes or no?
Yes.
So electric field lines are going like this, and you have already said that potential of point Q is greater than potential of point P. From here, I can understand a very simple and a very important logic. The relation between this direction and this potential. What is that relation? I probably told you that once. What is the relation between this direction and this potential? Relation between this pink arrow and whatever I've written in the red. Anyone? No one?
Opposite, sir.
What opposite, sir? Potential of point Q is more than potential of point P. Electric field goes in the pink direction. Anyone? No one. No one. That is no one, 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 no one. No one understands this? What I am trying to make? Well, then I must go back in time. And thank God I have a time machine and I have a written lecture that cannot be raised. Can someone read what is written in this? And does someone remember this? Has anyone
Yes, sir.
written?
Yes, sir.
What was that? This was past. And I have an entire record of your past, present, and future. Not the future, the past, present. And when your exams are over, and each and every question, I will tell you from which part of the lecture that question was. And if you are lucky, the same question I will show you in the lecture. Written. No fasana, only facts. Yes. So now you have seen the past, and now let me come back to the present. Yes. What do you see here? Can you again repeat? Yes. What did I show you and what I want to explain here? Please tell me. Okay. It seems like it has gone above your heads. Electric field is always directed from
Higher potential, lower potential.
oh, is that so? Was so difficult to understand? Is always directed from a point of higher potential to a point of lower potential. We have also seen this in the classes that we are doing on Sundays. Heat, 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 heat. always flows from higher temperature to lower temperature. Heat is electric field. Temperature is your electric potential, and we will see a lot of similarity between them. Heat flows from higher temperature to lower temperature. Electric field goes from higher potential to lower potential. Okay. Now let me see it in this way. Let us have a minus Q charge. And then I have this point P. Again, I have this point Q. Now, I have a negative charge here. Whose potential is more? P or Q?
P, sir.
Now the potential is more at P because Q is more negative and P is less negative. Less negative is greater than more negative. And that's that old maths. And now if I look at the direction of electric field, ding 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 ding. Electric field lines are going like this. No matter how they go, they're always going from a where?
To lower potential.
They're always going from a point of higher to lower, no matter what. No matter the charge is positive, no matter the charge is negative, and this will help us in identifying the direction of electric field in some questions. If you know which is at a higher potential and which is at a lower potential, we can actually identify the direction of electric field. Anyways, the point of contention was, what is the potential created by a point charge? The potential created by a point charge, if it is a positive charge, is plus kq by r. If it is a negative charge, is minus kq by r. Do we understand this?
Yes,
Yes
sir.
or no? But that
Yes,
was the
sir.
main intention, and this was the supportive intention to support it, that we also understand this thing from this. Have you noted this down?
Yes, sir.
Then comes again the same thing. Why I am keeping on repeating the same thing 2 or 3 times? Because I realized that we don't have any more chance of any more revision for electrostatics. So what we are doing, once we are doing it only once, and will not get any chance to revise it. Not possible in this universe. Maybe
Done,
after
sir.
JEE Main. For JEE Advanced, I may take a revision, but it's not possible before JEE Main. That is why I keep on repeating one thing 4 times, so that at least one time it will get inside your head. So what is this? This is the superposition principle. If I have a lot of charges creating a potential at point P, the whatever is there. You understand this now?
Superposition.
Principle of superposition. Okay, note it down, fatafat. We don't have the entire class to do this. If you have noted it down, if you understood this, don't have to note it down again. But if you have not understood this, any doubt, any confusion, we can only discuss it once, because kal hona ho. And kal to definitely will come, but kal we might not have the time to do it. Have you done this? Huh?
Completed, sir.
Well done, sir. What about the other students, sir?
Yes, sir. Done, sir.
Done, sir. Then, sir, this, sir, is no point of explaining what has happened here, sir. Graph wala question are very popular these days, and this is one of the graphs, potential created by a positive and negative charge. And what we have to understand here is, where is the point of zero potential? You can see the point of zero potential for a positive and negative charge will lie somewhere in between. Do we understand this? Yes or no?
Yes, sir.
if the both charges are same in magnitude, it will lie at the middle point. If the charge is more, one is more and other one is less, towards which side will it the point of zero potential lie? Towards the lesser charge or towards the heavier charge?
Higher charge.
Charge, sir, towards
Towards the
more charge.
okay. Try to find it out. Okay, do you understand these two graphs? Yes or no? Eh?
Yes, sir.
Thank you, sir. Chalo, have you noted this down?
Noting, sir.
Okay, sir. I'll give you time, sir.
Completed, sir.
Completed, sir. Everyone, sir?
No, sir.
No, sir. Then look at the diagram, sir.
Done, sir.
Okay, sir. Then, sir, this small question, sir. And I hope you can give me the answer, sir. Life starts with a simple question. And life consists of simple question. If you understand these simple questions, well, even the difficult questions are nothing but combination of simple questions. So, we have this arrangement. As you can see, I have drawn a magical arrangement. I have two charges, plus Q and minus Q. O is the, as you can see, midpoint. You have to find the potential at point O and at point A. You have 2 minutes to do it. Yes, but anyone with anything that looks like an answer. Sounds like one, feels like one. Huh?
V at O is 0, sir.
V at O is 0, sir. What about V at potential? Remember, whenever you are saying the absolute value of potential, you must remember that you are calling the potential of one point as 0. Where is that point?
Infinity.
Infinity. So assuming the potential at infinity to be 0, the potential at point A would be 0. Well done. What about point A? Huh? What about point A?
At point A is also 0, sir.
At point A is also 0. Everyone got the same answer? Yes or no? Yes or no? I'm not getting any replies from everyone. Shall I do it or you are
Do it, sir.
doing, sir?
Sir.
How do you find the potential at point O? To find the potential at point O, I see two charges. Let me call this as the blue one. What is the potential at point O due to this blue charge? What is the potential created at this point O due to this blue charge? Let me call this as V1. How much potential this blue charge will create? KQ by R. It is a positive charge. It will create plus K into Q divided by distance is A. Research potential is the simplest and easiest thing that we have encountered in electrostatics. What about this green charge?
Minus K Q by A.
Yes, that is simple. Let me call this as V2. V2 will be minus KQ by A. So what is the potential at point O? Sum of these two potential, V1 plus V2. And the answer is 0. So the potential of point A, point O is 0. Do we understand this?
Yes, sir.
Everyone understand this? Boys, girls, can I have a raise hand that everyone understands this?
Understood, sir.
What about point A? If I just join this dung 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 dung, both the distances are same. It will be under root of A square plus B square. Yes or no?
Yes, sir.
Yes, sir.
Distances are same. Charges are equal and opposite. So the potential at point A is also going to turn out to be 0. Yes or no?
Yes, sir.
Yes, sir.
In fact, if I take any point on this perpendicular bisector, all the points will be at the same potential. Yes or no?
Yes, sir.
If I join them, I will get a surface. That surface is known as equipotential surface. Here it is right now not a surface. It is just a point, but if I take any point on this plane which passes through like this, how do I make you understand this? This one. See, and this type of question will come in JEE advanced. Here I had made your. This is good. See, your 1 point charge is here. Your 1 point charge is here, and this is a plane here, like this. 1 point charge is here. 1 point charge is here. Right now, I took just one line of that plane, perpendicular bisector. On all the points on this line, the potential was same. Yes or no? In fact, if you take any point in this plane, every point on this plane will be equidistant from the point charge. Yes or no?
Yes, sir.
All the points on this plane will have the same potential.
Yes, sir.
That is known as the equipotential surface. That is known as equipotential surface. Anyways, we will discuss this equipotential surface in detail. Don't worry. So equipotential surface means all the points on the surface will have the same potential. All the points on the surface would have the same potential, and we have come across this equipotential surface before also. Where? Where? So in the dreams, I saw equipotential surfaces. That is what we are discussing. Where did we come across this equipotential surface before in the past? Are where? Where? Here, or there? Where? No one remembers it? Our old friend, wavefront. Wavefront was an equipotential surface. And your direction of propagation of wave was your electric field. Did I tell you that? Yes or no?
Yes, sir.
Okay. And there was a relation between that equipotential surface and the direction of wave. What was the relation between that equipotential surface, that wavefront, and the direction of wave?
Perpendicular.
Perpendicular. The wavefront, the direction of wave was perpendicular. Yes or no?
Yes, sir.
Now you can apply some ding 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 2 plus 2 4. So now you can understand the relation between what? Huh? Between what? Now you can understand the relation between what? Electric field and equipotential surface. Yes or no?
Yes, sir.
Okay. Since we have talked about electric field, what is the magnitude of electric field at point O? You can also tell me the direction, and you will see something fantastic coming up. What is the magnitude of electric field at point O? You can see potential is 0. What is the magnitude of electric field at point O? What is the magnitude of electric field at point O?
2k cube by A.
2k cube by
A.
A.
A square.
2k cube by A square. What is the direction?
I cap, sir.
I cap, sir. So if I draw the direction, sir, this is the direction. This is what equipotential surface is. And this is the direction. Okay. Let's not talk about the magnitude of electric field. Can you tell me what will be the direction of electric field at point A? I'll give you 1 minute.
I cap, sir. Sir,
Yes,
I cap, sir.
it is I cap. The magnitude may not be k cube by A square, but the direction is still I cap. How did you get the direction? This positive charge will create field in this direction. This negative charge will create field in this direction. The vertical components, if you can see now, the vertical components are going to cancel and the horizontal component is going to get added up. electric field will be in this direction. Now, does it remind you of something between electric field and equipotential surface? Does it remind you? What you can understand is this electric field is going to be perpendicular to your equipotential surface. Yes or no? Have
Yes.
you understood this?
Yes, sir.
Everyone, boys, I can't hear you. Are you there? Do you understand this? Electric field is always perpendicular to an equipotential surface. We understand this? Yes or no?
Yes, sir.
Remember this, a question is going to come based on this, not in your JEE Mains, but in your JEE Advanced. Electric field is perpendicular to your equipotential surface. So that is what we have learned, what is an equipotential surface and what is the relation between electric field direction and equipotential surface. One more thing that you have to understand here is, you can see very clearly that the potential at point O is 0, but electric field is definitely not 0. Electric field is definitely not 0. Similarly, at all the points on this perpendicular bisector, potential is going to be 0, but electric field is not 0. Electric field has a direction, in fact. It has a magnitude, it has a direction, in fact. That means, first of the important points, and they come as multiple choice questions in your exam, and the best multiple choice question on this E and V is given in SC Verma. I will discuss some of those if possible. The point that you have to understand here is, if potential at any point is 0, it does not imply what? It does not imply what? What? It does not imply that electric field is 0. Do we understand this?
Yes, sir.
Yes, sir.
It is the first point. Any of this point can end up in your paper as a potential question. If V is 0, potential at any point is coming as 0, it does not mean that electric field is 0. Have you understood this? And this is the best way for making you understand right now with a diagram. Have you noted it down,
Yes, sir.
boys?
Noted, sir.
Now comes this diagram. What is the electric field at point O? What is the electric field at point O?
0, sir.
What is the potential at point O?
0, sir.
Take a deep breath. Open your eyes and look at the universe. It's beautiful. Try it again. What is the potential at point O?
2k
Remember,
by A, sir.
how much?
2kq by A.
2kq by A. It is definitely not 0. That from here comes the reverse statement. What is the reverse statement? If electric field at any point is 0, it does not imply that
Potential energy should be 0.
it does not imply that the potential must be 0. But it implies one thing. It does not imply that potential is 0. It does not imply that, but it implies thus one thing. If electric field is 0, it implies that potential would be constant. Do we understand this?
Yes, sir.
potential would be constant. We understand this?
Yes, sir.
Okay. Coming back to your this equipotential surface ka diagram, you can see a very important thing written here, and everything that I've written are gems, because one of this gem is going to come in your exam. Electric field is perpendicular to equipotential surface. Now remember, the number of ways in which you can understand a statement, the number of ways in which you can say that statement means those many questions you have solved. Electric field is perpendicular to equipotential surface. From there, I can also write one more statement. And I hope everyone is writing these statements and not chilling out. In a direction, where perpendicular to electric field, what you can say about potential? Nothing, sir. What happens? Nothing I can say. What are you to do then? If I say something, everything, what will you do? Chill out. Yes. In a direction which is perpendicular to
There is constant, sir.
well done. And once you start understanding things, understanding with your own way, you will remember this. In a direction perpendicular to electric field, potential will remain constant. It cannot change. Potential cannot change beta in a direction which is perpendicular to your electric field. It just cannot change. Nothing can change it. Do we understand it? Or this has gone above our head saying bye bye, bye bye. I am going bye bye.
Understood, sir.
Okay, sir?
Yes, sir.
Your yes, sir is not looking confident, sir.
Yes, sir.
Okay. Now, since I talked about something, let me present, because that is probably the best way to make you understand this water, this water, this water. Shall इसमें होगा शायद वो. Okay, previous one. Just give me a couple of seconds and I shall be back with a bang. Instead of me making questions, it's good that you can use questions from the books. That gives more confidence. So here it is. So here comes the what? The question. It's a multiple choice correct question and it's from your favorite book. The electric field and electric potential at a point are E and V respectively. Multiple choice correct. Now these are the most difficult questions in JEE. Which of the option is correct? Yes, my dear friends.
C and D.
If E is not equal to 0, the electric field, the electric field and the electric potential at a point are E and V respectively. If E is 0, V must be 0. Is that option correct? Let us discuss one option, and that will help us in understanding.
Sir, all are correct, sir.
See, I have all are correct. All are okay. Let us discuss the first point. If E is 0, V must be 0. Is that so? No, we just saw the case where E was 0, but V was not 0. So this option is definitely wrong. Goes to hell. We move on to the second one. If V is 0, E must be 0. Huh? Oops. Right or wrong? We have just seen this is wrong. Yes or no?
Yes, sir.
Done. Wrong. What is this? So this is also wrong. If E is not equal to 0, and these are like negative statements might give you a lot of confusion. So whenever you get a negative statement, think about it. If E is not equal to 0, V cannot be 0. So you just have to find out a case where this doesn't happen. If E is not equal to 0, that means electric field is there. Electric field is there. V cannot be 0. Can V be 0 when electric field is there? Yes, this option is correct. Cannot be 0? No, it can be 0 as well. That means this option is wrong. If you can find any one case where this option is not valid, the option cannot be correct. Whenever it says cannot be 0, must be 0, maybe is a different language, must be and cannot be the different language. So you just have to find out one case where it is not valid. If E is not equal to 0, that means E is there. V cannot be 0. We can find out a case where V is 0. We have found out the case. E was not 0, but V was 0. So this option is also definitely wrong. 3 goes away. If V is not equal to 0, means electrostatic potential is there. Electric field cannot be 0. Electric potential is there. Can electric field be 0?
No, sir.
Yes, sir, it can be 0. So all the options are wrong. And all the 4 options can be proven right or wrong only with these 2 examples that I had given you. This one and this one. Now remember, the way the question would be asked in the examination hall would be in a confusing language. So that means if V is 0, E can be 0, E may not be 0. If E is 0, V can be 0, V may not be 0 as well. So if one is 0, the other may be 0, may not be 0. If one is not 0, then also other may be 0 or may not be 0. Do we understand this?
Yes, sir.
And all the 4 options were implying one thing. If one is 0, can the other be 0? Or if one is not 0, can the other be not 0? Both permutations, all permutation and combinations are possible. If V is 0, E can be 0, E cannot be 0, E may not be 0. If E is 0, V can be 0, V may not be 0. If E is not 0, V can be 0, V may not be 0. If V is not 0, E can be 0, E may not be 0. Do we understand this?
Yes, sir.
Different permutations and different combinations. That is why you'll have to understand the concept deeply with as many questions as possible, so that if any combination comes you should be able to get the answer. Have I made my point clear to everyone?
Yes, sir.
Boys, are you convinced?
Yes, sir.
Everyone convinced? Okay, now coming to the point where I asked you a question and I got a very revolutionary answer. This is a plus 2q charge and this is a minus q charge. Let us say separated by a distance of a. Can you tell me at which point potential would be coming as zero? That would be the last question for today. Remember, here I am assuming the potential to be infinity as also zero. That is zero. But apart from infinity, is there any point that you can find out?
Sir, minus Q, sir.
Minus q, sir? What do you mean by minus q, sir? At minus q, you cannot find out the potential at the point where the charge is kept because that concept becomes dicey. So if you are saying the potential is negative, is zero at minus q, that answer is not correct. You cannot define potential at the point where the charge itself is kept. I am the charge who is creating potential and you find the potential at my point only. Well, that is not possible. You can only find potential at other points which are not my points. Okay. Chalo. Having said that, can you find a point where the potential is zero? And you have exactly 2 minutes to do it. And it should not take rocket science. This is electrostatics. We're not dealing with rocket science. Yes, bacha. No one? It is such a difficult question.
Sir, one sec. The question repeat, sir.
Sir,
Yes, beta.
Sir, 2:3.
2:3. I mean, where is the point? 2:3. Where is the point? Tell me the point. Where is 2:3? Where is 2:3? I don't understand. Tell me the point. Where is that? I understand 2:3, but where is the point? Okay, so if I call this point as P, and if I call this distance as x1, and if I call this distance as x2, potential at this point has to be same. So I find the potential due to this blue charge. What is the potential at this blue charge? Due to this blue charge, let me call this as V1. It will be plus K into 2Q divided by X1. Yes or no?
Yes, sir.
And the potential due to this negative charge, let me call it as V2. This V2 should be equal to minus KQ by X2. Now V1 plus V2 has to be equal to 0. From here, I will get the relation between X1 and X2. What is the relation between X1 and X2?
2/3.
1:2, sir.
1:2. Correct?
Yes, sir.
That means 2 times X1 will be equal to X2. So how much is X2? Two times X1 is equal to X2. Are you sure? That cannot be the relation. Hey, Bhagavan. I think you will get X1 by X2 as 2.
1, sir.
This is the relation that you should get. Are you getting it?
Yes, sir.
So X1 will be equal to 2X2. So if I call this distance as A by 3, this will be 2A by 3. So remember, it will be nearer to the negative charge and farther from the positive charge. When I asked you this question, you said the opposite answer, and that is why I have done this. Do you understand this? Yes or no?
Sir.
With this, we come to an end of this class. I will continue this thing in the next class. We'll be doing more question of potential. Take care. God bless all of you. Bye-bye.